this video will be covering an activity that uses some of the fundamental R functions that are needed, and we use them very often, such as tapply, sapply, apply, summarize, mutate, and few others. So let's go over and take a look at this. What does it mean by this activity in this particular context? So if I just click up in here, I'm gonna find this activity like this. So if I just go there and I see that there are objectives which are widely used functions to be implemented into a data set. We will talk about the data set very shortly, but these are the functions: tapply, sapply, apply, summarize, mutate, and a few others. So the data set is like this. We have a student data set which is students.csv, and it has following columns: student ID, name, gender, age, test scores, math, science, and English, attendance, and their major. So the data will be built in CSV. It will be imported as a data frame in R, and then we will be, so this is look like a data structure of that, but then we have to do this apply, use apply function to calculate the average scores, and then we like to look tapply to find the average score for males and females. Okay, and then we have applies, and in this particular case the mutate, summarize, filters, select, and arrange. So these are very widely used built-in functions in R, and then we will build a R code around that. So first thing, as we see in the deliverables, it says that we have to deliver an R script, and it has to, let's say, write a report or explain this, how did you write your code, and the assessment will be based on how the code has been written. If the code is correct, produces the right results, how clearly code was written, and then if there is an explanation given as comments about the code, so that we can assess that the student has the right learning about the code which he has written. So coming back to this, we shortly jump into the code and as well as the CSV file. So in this video, we'll first work on how to get this R file. So let's go back and look into this code. There is a file name called student.csv. So you can simply click on here, you can download, and if you click up in here, it will download to your hard drive or local machine where you have, and this is the file we'll be using. So quickly after, we will go and show how the R code is working on this file. In this video, we're talking about how we can perform number of tasks based on the file that we just spoke. So first thing that we have to do is to incorporate this library called dplyr. So if you click up in here, that file has been built up in here. By any means, if you are not having this, so what you can do, you can simply go this dplyr, and you can actually say install it, gonna install that. But I assume that most of you have already installed. If you are already installed with, what you can do, you can simply call this like I called. So then what I would also need to have a read R files. So this will be the file that you, or the library that you need for running up. And if you again missing that library, you can simply read R, and this will be installing the library here. So I will not install because I've already installed them. And the other thing is that depending on wherever you have incorporate your file, you could actually import that. So I tell you a very easy way of finding a file. So if you click up in here, and since your file is the text files, so if I click up in here, this is the time it is importing the file as the students, right? And then you can see that these are the numbers. So if I click up in here, it's gonna show me this code. So this is the total code that the R has written in order to import the file. You can simply bring this code in here, and you can actually use this code, and you have to drop this arrow sign in here, and you can see that this code is exactly the same which the code I had. So these two lines are the code are exactly the same. So I would just simply avoid duplication and also avoid duplication in here. So I'm good. If I just incorporate that, it's gonna be doing this, and you can see that the file has been ready to be used, and I can see if I print up in here the print and then say students, it's gonna print it for me. So this is how I print. Now the thing is in here that if I would like to search for the help in here, so see what the help gives to me for the apply. So if I say help in apply, and this is the help I get it. So in this case that it says that returns the vector on an array of a list obtained by applying a function across the margins of an array. So what functions you like to apply and what are the margins? So these are the two things that we have to, and there are few things that are required and there are few things which are optional. So these things from there onwards are optional. We may not need to provide them, but then focus on what are the three parameters that we are like to provide. So in this case, if I provide this, stands for what? I would like to actually in my data set, if I just write it here students in here, and then I say okay, I select all rows, and then I say which column I'm going to select. So in this case I say okay, I'm going to select the math, okay, I'm going to select the science, okay, and then I'm going to select the English, right? And then what is the case in here that it is actually asking that look at this, what are the margins? So margin says that there are two ways. If indicates the margin one, like as if it is a matrix or a box or the table, the one indicates the rows and the two indicates the column, right? So if you go do the activity, and what is the activity which I like to do? I like to find the mean, okay, and one stands for what? Across the rows. So if I do this in this particular table, I want to get them in row and I like to find the mean. So this is the default function which I will apply here, and if I close the bracket in here, so this is how I can get my things in shape. So what is the first part will happen in here in this particular case, that I will first calculate this table. So let me just copy and reproduce it for you so that you see that what is being produced in here. So if I run it, I get the three columns only, and in this column if I just apply this, it gonna calculate the mean of each member. So in this case it calculated the mean for each of the 5 members, right? So these are the 5 members, one row, second row, third row, fourth row, fifth row. However, if I simply change that, right? So in this case, this is the average of each student, student 1, student 2, student 3, student 4, student 5, and these are the averages for each of these students. But by any means, if I just change this value to 2 and see what happens in this case, you're gonna get 3 values now. So if I change it to 2, stands for what? It will sum the means, but then in this case column wise. So I get the 3 values. So if I do this, I will see that the average across the math, average across the science, average across the English. And this is how we can compute this. So once this computation happens, it stores in this object. You can see that this object has been created, and you can see this object has been created in here. So if I run it up, I'm gonna see that the students, okay, and if I run it here, the averages, so you can see that there is one more column being created called average score. So this is how. And if I like to print the students again, I'm gonna see the new column which is being stored, right? For each student, which is row wise, it has calculated the averages. Now the next part in here is the t apply, right? So in this case, this is the t apply. And how do we do this? We will actually work out in this fashion to in this particular follow-up, we will create one more file to study how things are working in here. So suppose I'm going to create one file in here. So if I do create and two groups in here. So if I would like to work with the two groups in here, so let's see if I create the first one. If I run the first one, so this is a list. You can see in here it is a list. Okay, how do I know this? I say type of, and I say what is the characteristics. So this is the list. What we can do next is to write up in here. So what it's gonna do, this command, it will write up numbers from 1 to 9, and total number of rows are 3, and then it will put the numbers by rows in here. So that's what it says by true here. If I'm gonna do this, I'm gonna see something like this. You can see this 1 2 3 4 5 6. So it's happening from the rows, right? You can also do by column or by row false. Now what you can do next in here, we create another vector. So in this case, what we're gonna do, x in here. So this is the x, and then I say type of, and then say z. So this is how it says that integer, it's a vector. Now what we're gonna do in this particular case, we have the x, the list, we're gonna apply to the members of the list by using the apply. Okay, list apply. If I'm gonna do, then this is how I get the numbers, right? And if I print these numbers in here, I see something like this. So it has summed all the values in the x vector, which has these numbers 1 2 3 4 5, which make 15, and these numbers. So in this case, I get this up to 40. Now what happens in here, I have a very simple difference between the two. So in this case, a simplified version. So it's a simplified apply. So what will happen in this particular case, if I apply the same function in here, I'm gonna get the same number, but you can see the types are different. For example, if I write it here, type of, and I say the type of the apply list. So this is a list, you can see that it's a list, but then I say type of the sapply result, and this is integer. So this is the difference in terms of the categories, right? So how do you apply them? Now the other category that we have just created, prior to this, we create one more group category. So this is the group, right? So if I write it here, the group, okay. So if I see that there are groups, so the groups are repeated in two groups, which is group, okay, two groups in each of size 5. So this is the GL command. This is being used for create the groups. Now how it will apply, you can go with the tapply function. This is called tapply function. Why? Because it applies to a subset of this particular object which we created in here, z, right? So if I just look back in here, okay, and if I write z in here, so I get these numbers, right? Okay, so, and if I apply the groups in here, so if I apply the sum in here, so what I'm going to do here, that I say the z, so this is z, which has a list of vector starting from 1 to 10, and it has a group. So if I pass it on that group in here, so these are the groups which I have. And then if I would like to work up and say that I like to apply the sum function onto this vector, which is z, using the group. So if I work it up, I get the results in here. So if I do apply in here, I'm gonna see that in the group 1 there are about 15 sums, and the group 2 is about 40 sums. So this is how it will apply for this. Now similarly, what you can do, you can also apply by rows, right? So in this case, I have a y. Okay, this is a y, which is a matrix I created in here, right? And what I'm gonna do, I apply my results in here by rows. So in this case, it's gonna sum for each row in here. Okay, you can see that there are each rows, and each rows are being summed, right? So 1 2 3, 1 2 3 makes 6, 4 5 6 makes 15, and so on and so forth. And you can also do the same thing by column. So if I just change this number in here, okay, if I'm gonna just change this number to here into column basis, it's gonna change up, and you can see, so I say the call, right? So I create a new object called call, and if I apply the column result call, you're gonna see they are actually column based. Now the difference between tapply, apply, and these are for your convenience. Now before I go for a comparison, I'm gonna go and do what you call the multivariate apply, which is called m apply. So in this case, sometimes happens that you create your own function. For example, I'm going to take up two vectors and then sum them up, and result is as a summation of the result, right? So what I'm going to do, I create two vectors. So this is the two vectors, I created them, and then I create a custom function which will actually takes up two inputs and return the sum of that. So that's the function, custom function. And when I apply this, the mapply function in here, which is multivariate apply, it's gonna apply this function to each of the vectors which I provided. So if I do this, I'm gonna see that mapply result. So if I apply to this apply result, in this case, this is the result that I got. That means that it has added up these two numbers, 1 plus 10, 2 plus 20, 3 plus 30, 4 plus 40, and that makes the result. So if I'm going to print this up, I'm going to get this number so you can see that this is what happens in terms of my doing this, what you call a multivariate apply. So this is a very brief analysis in here. On top of this, what I have done, that if I go to the D12 page, you will see there is a comparison table being posted as well. So if you look back in here, you see there is a comparison table. So if I open this up, this is what it says, that lapply applies a function to each element of the list. Okay, the output is a list, okay, or a vector, and the input is a list or a vector, but the output is always a list. Okay, so actually it returns a list regardless of the input, whether it's a list or a vector. However, when you do sapply, simplified apply, which is the simplified version of the lapply, it tries to return a vector. So no matter you provide a list or a vector, it will provide you the vector or as part of the analysis. So this is one of the tries to simplify the output. The tapply is the application of the function on a subset. So it will apply to a subset of the vector and then results based on that. So these are the things. And then the apply is the more generic function which takes the margin either the row wise or the column wise and results on accordingly depending on the type that you provide. So these are the very fundamental differences. We will practice more, so based on the practice we will end up finding more understanding of these functions, but primarily these actually result a reduction in the workflow and ability to perform repetitive tasks without having to call the for loops or the do loops or any of the looping criteria that we have in other languages.